Hello world, my name is Alan. We're doing interview practice with LiveLeetCode problems. Tech interview practicing. I was tackling a hard level problem. Pre-story. And this problem it required a data structure that ordered set. Yeah. We don't have in the Go standard library. Well, there is, so there is this B trees from Google. I played a lot with the heaps over this practice, and it was good practice, I would say. quite a good practice. Now we have this other problem. Evaluate division. I think let me share it. So it's okay. What I like about it is it's from the first 1,000, and it has a pretty short title. Now it's kind of look at the list of constraints is like almost 10 lines, but it's let's see and what we can understand here. You're given an array of variables pairs, so it's an array of variables pairs. Array of, that'll be like AB, BC. So those are variables. And an array of real numbers values. Those are actually float, 64 types. Okay, float numbers. Where equations pairs are in equations, and values represent an equation. So it's always this first variable divided by the next variable. So it's kind of, what's the word for it? Correlation. So it's a division, okay? So A by B gives that value. And those values are floats. Oh. Ew. Well, let me use my pencil to write on my white paper. So evaluate division. So there's divisions. Division. Now, so we're gonna have these divisions. Each AB is a string that represents a single variable. Now you are also given some queries where query represents the jth query, where you must find the answer to also a division. Return the answers to all queries in a single if a single answer cannot be determined, return -1 if a single answer. Note, the input is always valid. You may assume that evaluating the queries will not result in division by 0, so there shouldn't be any zeros, and that there is no contradiction. You may assume that. Note, another note. The variables do not occur in the list of equations. The variables that do not occur in the list of equations are undefined. Oh. So we can like compile a map, separate list of all the variables that do occur. So like occur, if I can only spell that, is a map of string. So yeah, we can look at the queries that don't occur in the list of equations are undefined. Yeah, we can go through equations for range equations. Go through those, and so equations. Yeah, so we take an equation. We take 0, equation I would take its value 0 and its value 1. Those are pairs, and we call it a curve, but so we say that this equation true. Yeah. And now we know what actually occurs and what doesn't. Immediately. We might also want to know where it occurs. Yeah, not just the fact that it occurs, but also where. The occurrences, as I see, could happen in multiple places, but well, at least we know it. That's something. That's a small start. Now, how do we actually evaluate these equations? Do I remember anything from the math course? Anything from the math courses? Because if we have, like, if we know that A divided by B is 2, know that A divided by B is 2 divided by 1. And we know that, we also know that B divided by C is 3 divided by 1. So that, what was it called? or called proportions. I think they were called proportions. Yeah, I might need to look that up. Oh. What is that? Yeah, I think I might need to look that up because so if we have that A, B, C, D, okay. Oh, so they say that, oh, well, yeah. What that, yeah, let me just also share it here. So if A divided by B is 2, that means that A is 2B. Then also we have that B divided by C is 3. It means that B, wait a second, B divided by, yeah, if we multiply both sides by C, 3C, yeah. What that means if we want to know, so what would be A divided by C? And the question is, how much is A divided by C? That is, if we, yeah, I think we need to express A and C in, as we know, A is 2 B's, A is 2 B's, and we know that B is 3 C's. So you see now C by C is 1. So that's 6. Okay. All righty. Alrighty. I mean, that's the math of it. Same thing here for like, what is B divided by A? Yeah, we need to show that B, I know that B, oh, wait a second. Yeah, that's the proportion. B divided by A. Well, we know that it's like B, we invert it. Basically, it's what needs to happen is, yeah, we divide both of these sides by A and then by 2. So it will be 1, 2, right? Yeah, that's what it is. Then, and there is queries that don't exist. Yeah, when we have E that doesn't exist. Then, okay, A divided by A, that's 1, and X divided by X is nobody knows because X doesn't exist. Although it should be 1, should be, but we don't know. Because if, yeah, do not occur are the variables that do not occur in the list are undefined. So the answer cannot be determined for them. Well, yeah, naturally you would think like, I kind of know that whatever it is divided by itself, it's 1. But if it's, what if it's a 0? What if it's something we don't even know about? Well, that's the math of it. Computers are good with maths, but at the same time, I don't know. That's the math of it, but and how many of these equations are there? There's just 20. Oh, okay, there are limited numbers. And there's up to 20 equations. Up to 20 queries. Overall, it's, yeah, the variables have their length, consist of lowercase English letters and digits. A, B, C, D consist of lowercase English letters and digits. So basically, we want to know, like, we have a query. For I range queries. Yeah, we're gonna have queries also. Queries V0, V and V1. And essentially, we need to find out what that means. Yeah, so we need to find both of these values in the equations, calc equation. in the given equations. And then do the math. Yeah, we could do it just like 1 by 1. And I mean, the queries could be of different type. I see it lists like several types already. So one simple case is that one of the variables doesn't occur at all, and that's pretty simple. Yeah. If like v0 if it's not doesn't occur, or the next variable doesn't occur, yeah, then we just return. Well, then we need not return, but we append to the result is result E is -1 yeah, so that's pretty simple. Result is a slice of float 64 of length oh, it's okay, length queries. Make. So that's that. Well, the first case seems to be pretty straightforward. Another case is if they both exist, but they are equal, we just return 1. Yeah. Where is DFS here? I wonder. I'm still trying to understand. If value 0 equals value 1, yeah, this query, then result I is 1. Assign that. Those are. That's also pretty straightforward. So if both exist, but they are the same. Okay, the rest of the cases are these. Okay, there is another cases where both their variables are in one equation, and where vars are in at least 2 different equations. There might be more, but do we need more? To diff separate equations. Like in this case, where we needed to know what A divided by C was. We figured out, we expressed A through 2 B's, we expressed B with A is 2 B's, yeah. B is 3 C's. So eventually we expressed everything in C's. And by the way, we did need the B, yeah, so everything in C's, and C's were kind of, C's canceled. So now it's getting more interesting because these two options, yeah, when it's one, when both of them are in one, that's pretty easy. Like this B by 2, A, yeah, there's B by A. We know it's a type of equation. We kind of know the result for that expression, for that equation. Yeah, if they are both in one, yeah, let's try to solve that. To solve that, we would need to, do we need to, like, we could do a quick search. There's just 20 of them. I mean, yes, we can store them in a map. But, I mean, we can find where they are, whatever it is. Once we know the indices, like if, let's say, so if V0, if it's, let's say its position equals position of, yeah, if their index, if V1, if that's the case, yeah, we can easily do that. Let's say that positions of position of that is 1, position, oh, that is I mean, and position of that is I as well. Of 1, yeah. So we just need, pretty straightforward. Yeah, we can do it in one map, but yeah, so if we have them in positions, the same position, then all we need to do is say, well, it depends on which is what. If V0 so we know their position. Now there are two options. They are in both in one. So there are two options. It will be like A, B. Yeah, the equation that we have is direct. So it's exactly the value. or if it's the opposite. So if essentially, if in our query, if v0 equals, what is in the equation for that position at 0, just to simplify so it's not like, doesn't look too crazy. Position 0 is that. Okay, so if we then all we need to say that result so this is the map of positions. And if they're the same, then we say that this position, they have the same position, okay? Which is pos 0, and which is the same actually. So it doesn't need to be pos 0. It's the same position, okay? We can call it I don't know, what should we call it? Like position. We can call it I. It's the index essentially. By the way, we can all index, call it IDX. So so if they have the same if they're in the same index, then we'll look at in the equation, and if they are if they actually have the same relative position within that equation, then we just say a result at that position equals values at that position equals value at that position. So that's a simple case. Now the other case is if they're not, else if it doesn't, then it's the opposite case. Then we need to take it was like we had the result for AB, but the query is BA. So we need to do the query is BA, and that would be well, that would always be 1 divided by that value. 1 divided by that value. Okay, then the most interesting case, we think that it's about 2 different locations. I mean, these are the 4 cases. These are the 4 cases that we kind of see now. And I assume that having values in 2 different in 2 pairs is enough. I assume, but I'm not sure for, like, we had this, like, look at this second example, A, B, B, C. Okay, and we have A, C, C, B, B, C, C, D, C, D, B, C. Okay, that's kind of B, C, C, D. Yeah, these are the reversed one. Now A, B, A, B, B, A, A, C, X, Y. What if there is, yeah, because I mean the values, the variables, the variables, the equations. Could it be that the case is, that's a simple case, we'll already take care of it. What if there is like, we have a pair of A, B, and we have C, D, D, E, meaning we have like A and C. Like in this case, we have A, B, B, C. But what if it's A, C? Now I'm starting to see why it's depth first search. Yeah, because you might need to express that value. Yeah, you might need to look. Yeah, when you have, like, look at that. That means we can express A through B, C through D, and let's say that there is D and A, okay? And the query is about A and C. So that means to express A, you have A and D and A and B. To express C, you have D and A. Oh, C you can express through D. And yeah, so we have some values here. So that will be, we can express A through, yeah, B, by the way, doesn't help us like at all, because C we can express through D. B is kind of, well, if it's, let's say if it's A by D and there is a D, C by B, maybe like that. So, I mean, in this case, A, B, B, C, you had one common thing here, and you needed AC. Yeah, where is that? AC, A, B, B, C, and you needed AC. So B was kind of the common part of it to it. In this case, if you're looking for A and C, B and D is not common. Now, if you have A and D, or at least you have C and B, now you can express, you can say, what is B? Well, you know that B is C by value. C divided by value, yeah, so by its value. So you can start expressing, you need to go to the depth. Yeah. Yeah, because the target is we need to find what is A and what is C. And they don't have directly, they occur like in multiple places. So that's why positions cannot be this index cannot be just one value. Or yeah, we can like store a list of values. For this variable, we can see like where is it stored. Yeah. But yeah, now I see why it's depth first search. You'll need to go through, like if we have this A, yeah, can we like draw a tree? Draw a tree. What is A by B like? Well, like this thing. Can we draw a tree out of it? Do we need to? But I mean, for our understanding, we need to find the common, and they're actually connected. I mean, B B is here, C is here, D, the only one that like nobody knows what is D. And that, for that you will need like, we might need A, D. We might, we'll see. Timing. Well, I guess, yeah, I just want to draw this little tree and see if I, okay, because, okay, we're looking for A and C. A and C. And we know that A can be expressed through B. Here, B can be, B can be expressed through C. Okay, so now we connected it. So B can be expressed through C, and that's all we need. Right? A through B. B through, oh, because this CAB, CB, this connects it. Now that makes it too easy. Now if B doesn't have a direct connection through C, it has connection through D. Now that, yeah, when they have a, so A through B, B have a connection through, can be expressed through D, and now D can be expressed through C. Now that is, so we have C and C, essentially. So we can get our, so as you want to convert, what we're trying to convert one and get the other one here. Yeah, so if we express A through some equation of, through some equation of C, then we can remove the C's, and yeah, we know. So we just need to, we know the answer. So essentially, we were trying to, yeah, so A, B, yeah, and, oh, okay, so A essentially has, I see now. Okay, these pairs are sort of adjacencies. Okay, so we'll look through, but they're both. They're mutual adjacencies. So this is kind of a graph. Yeah, this is kind of a graph. This first graph is sort of a triangle. Yeah. It was A, B, B, C. Well, A, C are not connected, but A is connected through to B, and C is connected to B, so that's what we needed here. But it could be more interesting, like in this case, In this case, where we have, if it's like A, B, C, D, B, D, B, D. Yeah, in this case, we know that A is connected to B. A is not connected to anything else. It could be, but it's not. Now B is connected to D, and C is connected to D. Okay. And we need to build that link. That's where it looks like a DFS. But it could be several connections. Yeah, like each of them could have multiple other connections. Do they repeat? They might be repeating, which will be just the reverse. Pairs. I'm not sure they. The ones that repeat like ABBA in the reverse, they just will not add anything to the graph, anything new. So we need to start from A. The logic will be we'll start from A. We'll be looking for everything, since this is a depth first search. Oops. Depth first search. We'll need if we want to do depth first search, because we just need to find one connection that leads to like the connection that leads to C, and we will be like expressing A through all other variables until we can express it through C. Yeah. It's gonna be a path. So we'll be like trying all those paths. To do that, we might want, well, we definitely don't want an iteration, but we do want to know, okay, what are the connections of A's to anything else? What are all of the, we need a map that will store like A is connected to B, A is connected to C, A is connected to whatever it is. And maybe the product of that connection value. Yeah. yeah, like if we express, yeah, like, yeah, that's the logic. Yeah, we'll just need to think through the details, but that's primarily the logic, and we'll do that probably tomorrow. That's good practice. Thank you for watching, and we'll see you in another video.